This is going to be a video on just balancing with oxidation number method. So when you see a reaction like this, you can use your conventional method and trial and error, but it's probably going to be pretty difficult. So one way of doing this is using the oxidation number method, and you're just looking at the oxidation numbers and how the electrons then transfer. So here's a reaction that's identifying assign all the oxidation numbers first. So that's -2, -6. And then this is going to be +1, and then +5, and then +5, +1. This is going to be a +2 because this has an overall charge of -2, because nitrates, each of them will have 1, and you have 2 of them, giving you -2. So this would be -6, +5, +5, and then over here would be -4, +4, +4, and then -2, +1. So the next step here is that you have to look at which one is oxidized or reduced, and you can see that this one has lost 2 electrons. This is your oxidized one, and the next one is going to be your nitrogen. This one went from a +5 to a +4, so it has gained 1 electron. So this is your reduced. So in the oxidation number method of balancing, you first have to assign your oxidation numbers and then see the redox reaction, and the next thing you have to do is basically looking at the lowest common multiple of these electrons transferred. So what that means is that here in this copper has lost 2 electrons, and for nitrogen has gained 1 electron. So the lowest common multiple of this is going to be 2, right? Because if you multiply 1 by 2, you'll get to the other one. So what you're going to do is actually going to multiply this by 2 to get to 2. That means that this number that you have multiplied by, that's going to be your coefficient, so that's going to be 2, and then you have to change for the other one has 2 as well, so that will give you 2. And now once you have done that, your reaction is not automatically balanced. You have to double check it. So let's check this one out. So you have 1 copper here, 1 copper here, so the coppers are good. You have 2 hydrogens here, 2 hydrogens here, so far so good with the hydrogens. And then the next one is that you have 2 nitrogens, so then there's 1 here, and then you have 1, 2, 3, 4. That means that you have too many nitrogens on this side, so you have to double check. And I'm going to put, instead of 2 here, I'm going to change to 4. So you do have to go back and check your answers. This offsets your hydrogen, so because now you have 4 hydrogens, so I'm going to put a 2 in front to make this hydrogen 4. So the hydrogens now are balanced. My nitrogens now are balanced because I have 4 here and then 4 on the right side, on the product side. Now let's see if my oxygens are balanced. So I have 4 times 3, I have 12. Here I have 3 times 2, it's 6 oxygens, plus 4 here, that's 10, plus 2. So finally all my oxygens are balanced. So this is the oxidation number method. Assign your oxidation number, and then you have to use the lowest common multiple, and then that change your coefficients to that. But don't forget you have to go back and double check because it's not automatic. As you can see, that I had to change the 4 to make this work. So let's look at another example. Here we have another one. So then let's assign some oxidation numbers here. So here Cl is -1, -1, hydrogen is +1, +1. This is my nitric acid, so this is -6, +5, +1. This is the same as the previous example. And then for this one, HOCl, this one is kind of a different one. But if you look at HO, this is your hydroxide. So hydroxide here has a -1 overall charge, which makes sense because your oxygen is going to be -2, and it's more electronegative, so it's going to be -2, which this -2. And because the left side here, this HO has to have a -1 overall charge, your hydrogen has to have a +1. And to balance this out, then the Cl actually, instead of being a -1, becomes a +1, and then that's how we do that one. For the other ones, here's -2 for oxygen, +2 for nitrogen, and water is going to be +1, -2. So let's identify the redox reaction here. Nitrogen is going to gain 3 electrons, so this is going to be your reduced one. And then we can see that your chlorine here has lost 2 electrons here, making it oxidized. So now we have to, the next step of balancing this, then we have to look for the lowest common multiple between these electrons that's been moved. So 2 to 3, and the lowest common multiple is going to be 6, because if we multiply this by 3, it's going to equal to 6, and if we multiply this by 2, it's going to equal to 6. So then, because we're multiplying these two by 3, we're going to put 3 as the coefficient here, and if we're multiplying this species by 2, and also this species by 2, then I'm going to put the coefficient here. So that's the first step of the oxidation number method. The second step is actually checking if they're balanced or not. So I'm going to change a different color. So let's look at the number of hydrogens on the left side. 3 HCl, so that's 3 hydrogens, and 2 here, so that's 5 hydrogens. So 5 hydrogens on this side. On the right side, I have 3 hydrogens here and 2 on this side. That means I have 5. So far so good. Let's look at the CLs. I have 3 HCl, so that's 3 CLs here, 3 CLs here. So the chlorines are balanced as well. And then let's look for my nitrogens. I have 2 here, and then also 2 here. And last check is for my oxygen. So let's look at this. We have 6 oxygens here. That's good. And hopefully this one we have 6. So we have 3 plus 2, which is 5, plus 1 gives us 6. So they're all balanced. So this is how you balance it without really trial and error. That's why this oxidation number method is pretty useful, because you can get it without your trial and error method. So this is the balancing with oxidation number method. The next one is actually splitting your half reactions and balancing with half reactions in an acidic solution and in a basic solution. Those ones are a lot more involved, so be sure to watch those and practice those questions. So see you later.